This is video 2 for chapter 5.3, logarithmic functions and graphs. Hopefully you've watched the introductory video. If you haven't, go ahead and go back and do that now. So the logarithm of x with base a is identified as. So I want to go ahead and put a formal definition out there for the logarithmic and the exponential, which hopefully you realize that logarithmic and exponential functions are very much linked, just written in two different ways. So y equals log base a of x. That is our logarithmic. That is our logarithmic equation. A couple of things is that, let's label a couple of things. The a is what's called our base. It is a subscript, and that's our base. And it's the same thing as the base of the exponential function. X is called the argument. Now, this logarithmic function is equivalent to an exponential function. It says that the base, a, to the power, which is going to be y, equals the argument x. There are a couple of specifications on a and x. X has to be positive. This is the biggest thing. Our argument has to be positive. You can't have something to a power be negative. It's not going to work out like that. So make sure that your x value is always positive. And a has got to be bigger than 0 as well. So what I just said, that something to a power can never be negative if the base is positive. So that's kind of where we're going. And a cannot equal 1. It's kind of the same thing that we talked about before. Now, our logarithmic function is read like this. It's read log base a of x, where again, x is the argument, a is the base. There's a couple of logarithms that are so commonly used that we have special names for them. This one is called the common log. Again, this is most commonly used a lot in chemistry and physics, that it's so commonly used that it has a special button on the calculator and we don't write the base. So the common log is always log base 10 of x. Now, when you write this, they normally write it like this, just log of x. So when there's no base, there's an understood base 10. Understood base 10. So that's what you're going to have to remember. If there's no base, there's understood base 10. Now again, the logarithm is just another way of asking this question. The base to what power equals the argument? That's the biggest thing. The base to what power equals the argument. When I was in high school, my teacher always asked, what power is it? That is the big question. That's what logarithms are really asking. It's asking, what power is it that you raise that base to get the argument? So let's look at some examples here. Find each of the following logarithms without a calculator. So this is done without a calculator. We're using the question, what power is it? So again, what power is it that you raise the base to? So the base to what power equals the argument, in this case, which is 25. So 5 to what power equals 25? Hopefully you know that 5 squared is 25. So log base 5 of 25 equals 2. That's the answer, 2. Remember, logarithm just means what power is it? So let's look at example 2 here. This says, what power is it that you raise the base 3 to give me 27? Well, 3 squared is 9, so that's not it. 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27. So 3 to the third power is 27. That's our answer. So log base 3 of 27 is 3. Let's look at number 3. It says log base 6 of 1. This one, same thing. What power is it? Do you raise 6 to give you 1? Well, we have 6. 6 to the first is 6. 6 squared is 36. We're getting too big. But key thing, remember, anything to the 0 power is 1. So log base 6 of 1 is 0. If you have anything, in this case, this is kind of a special one, log base anything of 1 is 0, because anything to the 0 power is 1. Always, always, always. Let's look at the next one. Log base 5 of 5. Well, this means, again, what power is it? Do I raise the base to give me the argument? Well, 5 to what power is 5? It's not 0. 5 to the 0 is 1. 5 to the first power is itself. Anything to the first power is itself. So again, log base 5 and 5 to the will end up canceling, giving you 1, and we'll look more at this later. Number 5, this one says log of 10,000. All right, here's the problem. There's no base. But remember, we already talked about this. What is no base? If it has no base, it has an understood base of 10. So if you want, you can rewrite this as log base 10 of 10,000. Understood base 10 there. So this means 10 to what power is 10,000? Well, if you need to, you can get your calculator out. 10 raised to the second, hopefully you know, is 10 squared is 100. 10 raised to the third is 1,000. Nope, we need one more 0. So 10 raised to the fourth is 10,000. So in this case, 10 to what power is 10,000? This is 10 to the fourth power. So log of 10,000 is 4. All right, this last one is your turn. Go ahead and figure this one out on your own. Hopefully you got that right. So now we're going to move on to finding them with the calculator when you can't find it without a calculator. So if you bring up your calculator here, I want you to look for the logarithm button. And if you look, it's right here, right next to the number 7. It says LOG on your calculator. Now, if you look at number 5 right before here, this one is the LOG. Now, again, this is the common log. This does not work with anything that has a base. So on the previous examples that we looked at, the only one that we can put in the calculator is number 5. Okay, because it's the only one without a base. So again, notice that 1, 2, and 3 here, these examples don't have a base. So looking here, find the common logs with a calculator. Round to 4 decimal places. So here, all you have to do is type it in. You hit the log button. It opens a parenthesis, so we will have to close it. 6, 4, 5. 7, 7, 8. Close your parentheses, hit enter. There's your logarithm. Now, does this make sense? Remember, this is 10, log base understood 10 to what power equals 600,000? Makes sense that it's going to have 5 zeros behind it, so it's going to be to the 5th power. So this is, we're getting close to a million, which is 6 zeros, so that's a good indication that we're on the right track. 4 decimal places, so I have 5.810. Let's look at this second 0. That's my 4th decimal place. The 8 rounds that 0 up to a 1. The next one, this says log of 0.0000239. So this asks, what power is it do we raise that understood base 10 to get this really really teensy tiny decimal. Now, I'm going to give you a hint here that this should be a negative. The reason that this should be a negative is 0.0000239 is you can rewrite that as a fraction. This is a fraction. So the only way to get from 10 to a 1 over something is going to be with a negative exponent. So we know our exponent is going to be negative here. But we can go ahead and just plop it in the calculator. 0.0000239. Close my parentheses, hit enter. This again is negative. If it's not, I did something wrong. 4.621. Let's look at our last decimal value. This 6, there's 0, don't round. So leave it as a 6. The last example is going to be your turn. You will go ahead and put this log of 223 in the calculator on your own.